All right, let's kick things off. Thank you for joining Interface today for another one of our Force Leaders webinars. Today, we're going to take up the topic of machine building and automation, two very common use cases for interface, precision, force measurement, torque, and instrumentation devices. We're excited to have our presenters today, Jeff Boyd and Jason Graham, who have a lot of experience in this area. I'll be sharing a lot of technical insights as well as application ideas and product information that's relevant to this topic. So before we kick things off, please use the chat feature for any questions that you have. We'll try to address them throughout the event. And note that this is recorded and we'll be sharing this with anyone that's registered for the event. Again, thanks for joining Interface, and let's kick things off. Jeff, Jason?
Right. So next slide. So powering up machine building and automation agenda. So today's topic will be discussing modern machine building and force measurement, essential sensors, instrumentation that's associated with that, the building machines that require precision. Why do we do it? What are we doing? Unlocking the automation potential, emerging trends, pro tips and best practices, as well as application uses and cases. Modern machine building. So essentially, we're summarizing 3,000 years of machine building over the course of a few bullets here. So if you start and you look way back, ancient tools, levers, wedges, incline planes, that's what we use to manipulate our environment. So then that's like 1,000 years BC. So we start looking at Greek scholars, Archimedes screw, that was one where we used a screw to move water up or down, pulleys, levers. As you progress into the 18th and 19th centuries, so we're getting into steam power, innovating machines with like the cotton gin, the loom. Manufacturing and machine building is definitely becoming more complex, and it's offloading a lot of the manual things. 20th century and beyond is where we start looking at electricity, automation, computers. This is where we start bringing in automation and tying all of our sensors and things into together. The 21st century, that's where we start looking at miniaturization, where we are today, artificial intelligence, Internet of Things. How do we take our sensors and tie them into wireless, Bluetooth, etc. Machines using sensors. So if you start looking at how machines were using sensors or how they were first integrated, low profile load cells, we started using those to measure fatigue, durability. Miniature sensors were then used, and that's where you start looking at real-time feedback loops, control loops. Sensors are actually taking sensor information, feeding it back, and that's where we get that real-time feedback. Transition to wireless as well as Bluetooth, that's definitely the Internet of Things, and then for multi-axis sensors. Advancing to automation of functions and control use sensors and instrumentation. So as we move forward, our instrumentation is going to interface a lot better with our PLCs, other devices that allow for increased automation and that machine environment. Next slide, please. I think this is
right.
you,
Yep. So here we're going to highlight many of our products, and we're going to touch on some of their features and key benefits, as well as how they can be used in machine automation, if you will. So the first product that we're showing here is our low profile model 1100. And it's our ultra precision load cell. Some of the benefits that you see is our proprietary interface strain gauges, temperature compensated strain gauges. Key features there is that we don't require to have any additional temperature compensation network. The strain gauges are all that's required, so therefore we have less junction points, less solder connections internally within the Wheatstone bridge, and it has many advantages there. High precision base is included on our 1100 series, and to touch on a little bit of how it can be used in machine automation, it could be used in a control loop, like Jason had talked about, where you can monitor in real time, maybe adjust parameters as you're measuring and as the machine is running, and enhance the machine's performance and throughput. Next slide, please. Here we're talking about our 1200 series low profile load cells, but we have integrated IO-Link amplifiers to these, again, using the same proprietary strain gauges that we do on the all of our low profiles for that matter. But IO-Link communication, the advantages there is that it gives you advanced functionality over just a strain gauge output. So the data communication is digital, bidirectional communication between the load cell and the controllers. It's digital signal, so very high noise immunity. You can remote configure and do diagnostics, and allows for very seamless integration into machine automation that have PLCs or HMIs. Next slide, please. Here is another example of our low profile design, if you will. It's a stainless steel version. So you may find this in more of a, harsh environment, perhaps a hazardous location, food industry may take advantage of, a stainless version of our low profile. So very, very versatile. Again, corrosion resistant and very, very good for harsh environment, perhaps outdoor use. Next slide, please. The miniature beam load cell, again, using our proprietary strain gauges there. A very compact size, low deflection. So that's another key performance. Very, very good performance to 0.03%. And these can be used in many machine automation where you're needing accurate and reliable force and weight measurement. Again, small and lightweight, highly sensitive, and economical. Next slide, please. Rotary torque. So kind of getting away from force measurement here and talk a little bit about torque. This one is a rotating torque sensor, so we can measure dynamic torques. Some of the advantages here: high level analog output, plus or minus 5 volt, or plus or minus 10 volt. Keyed shafts is a feature that can be integrated into the T18. High performance, non-contact signal transmission, so not any wearing brushes or slip rings, that sort of thing. Something, an application, good use case would be perhaps torquing a bolted joint. So dynamically measuring torque, you need to keep your bolt torque to a specific or within a specific range. Our rotary torque sensor can provide that feedback and ensure that you're not over torquing it, perhaps damaging the fastener or the joint, or under torquing and creating a poor bolted joint. Slide, please. The AT104. So this is what we call a multi-axis. It measures not only torque, but also measures force. It can provide, monitoring and control, and is a static device. So, right, it's not rotating. It's going to measure torque statically and force. Very short axial length. You'll see some of the benefits there that we talk about. Reliable, durable. And again, you may find this in a machine where you're doing research or quality control functions and measuring force and torque simultaneously. Next slide, please. Here we're talking the AT105. So this one now is rotary. So it's measuring force and torque on a rotating device, and is again contactless digital signal transmission from the rotor to stator. So again, no wearing brushes or slip ring assemblies that you'd run into here. So very maintenance free. Again, this could be used to continuously monitor, torque and force on a specific component, screwing or fastening, grinding and polishing, where specific force and torque is required to maintain a consistent finish on a product, is also an application we've seen these used in. Next slide, please. The T33 spindle torque transducer. So this again is a rotating torque sensor. High level analog outputs, ±5 or 10. Can have integrated speed and angle measurement. So if torque and speed needs to be maintained or controlled within a specific limits, you can do that with this type of device. You can monitor torque levels, make sure that your machine is running and operating as efficiently as possible by integrating this into some type of torque control loop feedback. Next slide, please. Multi-axis sensors. So this is commonly used when you need to measure forces in more than one direction. For instance, X, Y, and Z all simultaneously. A nice compact design on this 3A series that we're showing here. Low crosstalk and is temperature compensated as well. These are used in applications very often in robotic applications, maybe end effector, and can trigger. You could send a signal to trigger an alarm or shut off a machine if you notice that parameters are getting outside of expected ranges. Next slide, please. So here is another multi-axis. This one's measuring 6 axes, so it's measuring all 3 forces and all 3 moments. We would provide that with the matrix so that you can do the corrections for the math for all the axes. Again, you're measuring 3 forces and three moments. And again, the very high precision, low crosstalk can be integrated into many applications where those measurements are critical, and you need to know about the forces and moments. Next slide, please. Now we're getting into instrumentation. We're showing here is our portable handheld data logger, model 9325. You can see some of the benefits and features here, 2,400 samples per second, high internal resolutions, IP64 rated, supports TEDs, templates 33, 40, and 41. It does have features built into it for, that you can monitor process control application. We do have a version that comes with software and a USB port, or you can stream data from this device from a load cell or torque sensor or whatever you have connected to it to your PC and monitor the data and record it to our BlueDAC software. Slide, please. So here we're moving on to our model 9890 strain gauge load cell display. Very large display, LED display, so very easily read from across a room. Peak and valley monitoring can be set up to monitor performance of a machine, make sure you're operating within desired parameters. has tier features, linearization. So again, a very nice product for integrating into, an automated process where you need to sound alarms or, you know, shut off a process if things are outside of the desired performance. Our BX8, probably one of our most powerful instrumentation devices that we have, is commonly used with the 6-axis as well as the 3-axis, or can be used with the 3-axis, but it could also be used with individual sensors if you have a need for up to 8 channels from a single BX8 module. Those can be linked together to give additional channels if you desire. Has very high sample rate, 48,000 samples per second, synchronous across each of the channels, 16-bit scalable analog outputs, 16 digital IOs, and we'll do all the internal math calculations for the 6-axis load cells that we talked about earlier. So you just input the matrix that, or we would do that for you, and it will automatically calculate the true forces and moments and provide those as calibrated analog output signals. So very powerful device, and can be integrated into most machines. Load pins. We're showing here kind of one of our standard load pins. This one, made from I think they all are made from stainless steel, actually. You can see we have a keeper plate shown in this one as well. Keep it from rotating in once it's installed. Keeps the axis oriented for optimal performance. And these are commonly found in applications for like lifting, hoisting, safety monitoring. So you want to make sure that you're not picking up something that was heavier than what the crane or the hoist is intended to lift. So you can, again, send the signals and provide feedbacks, audible alarms, signals, sirens, whatever that may be. We have versions that are capable of being used in marine applications and offshore submersible versions, wireless versions as well. So very rugged product. Doesn't quite perform as well as a low profile per se, but provides very high accuracy for the application. Here's a more custom load pin. This one does show our wireless module on the end, and the blue component there, so that houses the wireless transmitter as well as the batteries for that device. IP67 rated. Again, some of the features that we're talking about, submersible versions, integral cable if it's not a wired version, outputs of plus or minus 10, 0 to 10, 0 to 5, 4 to 20, and 4 serial outputs as well. We do make them for hazardous environments as well, and TEDs can support TEDs as well. Tension link load cells. So we were showing a couple of versions here, a junior and a standard aluminum wireless tension link. So again, sending the signal wirelessly back to a control module that can provide analog outputs, or you can take the data directly to your machine for measuring, very common again, measuring for hoisting and lifting, cable tension. So where you need to have parameters met, maybe alarms that go off, this is another option where maybe a load pin you can't fit into the application, perhaps a tension link, you have room for that and can more or less monitor the same thing. Next slide, please.
All right, this one's me. Building machines that require precision. Next slide. So machine building, testing machines. There's a variety of different machines when you start looking at machine building. A lot of these kind of are similar on this first page. So tensile testing machines, compression testing, and universal testing machines. If you look at tensile testing machines, you're looking at something where we're trying to pull apart materials and break it, or you're doing something along those lines. We want to determine how you can instrument that so you can determine the amount of force it takes for that. Some manufacturers or folks need that. Likewise, instead of the pull part, the compression, that could be a part. If you start thinking about random components, I'm going to say bolts, nuts, things like that, whether it's tensile compression testing, whether it's fabrics, different things, a variety of them will be used in different industries. Universal testing machines, that's just something that it may have all of those features in one, and you can kind of do compression, you can do tensile, you can do a little bit of everything. Next slide, please. Forming machines. So when we start looking at some of this, forming machines, so that's where you're going to take sheet metal and we're going to form it. There's different ways of doing it. By instrumenting it, it prevents us from overforming it and preventing problems. Also underforming it. Welding machines, when you start looking at welds, we start looking at joint strengths, the amount of pressure applied, are the welds good? Welding machines, I think that is really common when you start looking at spot welds and the pressure at spot welds, the surfaces together, and then the pressure for the spot welds. Assembly machines, you're looking at robotic assembly lines. So anything that we can do to offload human interaction and have assembly machines do some of that work. If you can instrument it, it helps get that feedback loop. It prevents damage to some delicate components. You get a more consistent assembly. It's just a good direction to go. Packaging machines, when we start looking at packaging machines, so you're looking at the correct amount of product in a package. So that could be a bottle, that could be a box, that could be a container, it could be rolling on a conveyor belt, it could be, something. So we have, there is the potential to put a load cell so you can instrument either weighing the product as you're dispensing it, as you're rolling it along the production line or the conveyor, a variety of different ways that can be done. Next slide, please. Clinching machines. So this is where we're using a combination of force and pressure to join sheet metal parts. There's no need for welding. You're basically just clamping the two together for a secure joint. Force feedback or having some type of force measurement on that is exceptionally important. When you start looking at material handling and conveying systems, it's just like the prior bullet on the previous page. We're weighing and tracking materials. We're watching them as they go down conveyor belts. You can instrument and see, did you dispense the right amount? Is it insufficient? Is there a problem with your line? Is your line holding up? And now you have a huge mass in one area. So that's your feeding systems and whatnot. Press machines, it's kind of like stamping presses or forging machines. We're looking at the forces exerted like during the press operation. So a lot of this is going to be kind of like your hydraulic presses and things along that line. So you'll end up with a load cell or something either instrumented, load pin, where you can monitor a force from a press machine. Next slide. Balancing machines. Balancing machines, this could be done in a variety of different ways. So if you have a rotating object, you may find that object is imbalanced. So it could be rotated slowly, quickly. With a load cell, we can identify with a centrifugal force an offset in mass or weight. And by correcting that, and this allows us to do it. It can be done in a rotary fashion. We have a sensor that allows that. And then there are some ways that it can be done with a sensor below. Robotic assembly lines plays a crucial role in ensuring precise force control during robotic assembly tasks. So if you start thinking about the automation industry or car industry, I can't count the number of robotic assembly lines I've seen. It's a time saver, quality improvement, helps with people. It allows robots to pick the parts, put them in the right place. You just get consistent quality in builds. Next slide, please. So machine performance monitoring and predictive maintenance. So one of the benefits when we start looking at machine building and instrumenting just machine building with some type of load cells, they can be placed in different positions. As they're placed in different positions, we can monitor the load cell loads, different, I would say, situations, so that we can determine if there's a wear, zero balance is shifting, that machine needs more maintenance, bearings, gears. So there's a lot of different ways that we can get feedback on that maintenance. Likewise, I think Jeff had alluded to an IO-Link load cell, which does provide diagnostic feedback. So there's other load cells that do have some features similar to that too. 3D printing machines. It's not super common yet. A lot of the advanced 3D printers, you're starting to look at the deck where the 3D printer goes. So the print head will go to the deck in a variety of different positions, and load cells can be used for ensuring that the deck height is exactly the same, or it can be adjusted so that the tip produces the correct amount during the extrusion process. So not very common. It's kind of a trend that we're seeing. Next slide. Unlocking the potential of automation. Next slide. So there's quite a few benefits to automation. One of the first would be productivity. So you start looking at advancing manufacturing and you start using automation. Robots, you're going to get smart automation. Your mundane repetitive tasks that humans would do on a manufacturing line, robots are doing it, so those tasks aren't being done. It allows them to use their judgment. Humans use their judgment, think, do the more complex tasks, and allow the robots to do the repetitive stuff. Productivity increases. It's just a good step in the right direction. Quality of output in products. So as you increase automation, load cells will improve your product quality. We're going to see better precision control, better consistency. We'll be able to detect errors. We'll optimize our output. After all is said and done, by using that, we will have a much better idea of what the output will be from that process versus kind of an unknown. So quality will definitely be up. Next, accuracy of tasks. So if you start automating your tasks, load cells can start giving you precise feedback. So when you start getting into control loops, PLCs, stuff like that, you can have robots or automation where we get to a point where devices are actually doing things. We get a feedback loop and we either need more pressure, less pressure. So that's a very, very important thing. Workplace safety. So as you automate workplace safety, sensors drive this from a variety of different angles. So if I was to look at crane lifting or something similar to that, and you start looking at somebody's lifting something, there's overloads, there's weights that you wouldn't want to exceed. So by instrumenting that, doing things similar to that, load pins, shackles, a variety of different things, it allows us to ensure that workers aren't put into a position where they could be hurt. Next slide, please. Risk prevention and maintenance. Load cells, they enhance accuracy. So instead of kind of that we're precise measurements. We're down to decimal points way out there. We get feedback immediately when something's occurring. Consistency, error detection. So just as an example, there was a case where we had a large object that was being lifted manually. Once we were able to work with the customer and instrument that, there was a multiple $1,000 savings as a result. So risk prevention, maintenance, a lot of those things came into play. Cost savings, likewise, it was reducing scrap and rework as a result of the automation, the improved quality, the feedback, consistency, error detection, all of the prior things. It led to a cost savings as a result. Reducing labor costs, scrap. It was just a good thing. Next slide, please. Data collection. Provide real-time monitoring, accuracy, comprehensive data. So a lot of times when you are you have load cells instrumented into automation, you need to aggregate that data and store it in a place, kind of make sure that what your processes are doing are falling within the constraints that they're supposed to be. So this is where we start looking at process optimization. Jeff pointed to, is the load cell identifying maybe a process that we can improve, make faster, better? Predictive maintenance. Are we seeing a trend where a load cell or an instrument or a machine is starting to degrade? Quality of readings are starting to degrade. So we can see that and look at that for continuous improvement. Control by providing accurate measurement, the closed loop feedback. So this is essential when you start looking at force sensor detects something, could be normal, could be abnormal. That sensor reading goes back to a control circuit. Control circuit acts upon it, sends a signal back to a control effector that would then either move it something so that we can not be out of the loop or the standard, whatever it is, whether it's safety, quality, data-driven. Any of those things can drive improvements in our control. Next slide, please. Scalability. So when you start looking at automation, this is one of the largest things that automation does for any manufacturer. Provide scalability, flexibility, adaptability, performance optimization, and quality assurance. I think the challenge when we start looking at this is hardware integration and cost considerations. So if you have older equipment, stuff that hasn't been updated, and it takes a little bit more effort, it could be a little bit more challenging to get the right hardware integrated into the right places, instrumented in the right locations. We have people here that help mitigate that. We work with everyone on the proper planning, make sure that the design and implementation works and it meets your automation needs. Next slide, please. So automation with torque, and Jeff spoke about 3 or 4 slides about different torque sensors. We can automate with torque, looking at torque measurements, monitoring, control, whether it's assembly processes. You're starting to look at torque on bolts. Is it too much? Is it too little? Safety, quality assurance, any of that. We can do that with a variety of different torque sensors. We have sensors that can do the static torque, rotary torque. So there's a bunch of different options available. Automation with multi-axis. We've got 3-axis, 6-axis. So when you start looking at robots and you start looking at, say, like end effectors or something where you want a robot to do a specific movement, automation with a multi-axis may be part of that. It could also be seen in base plates, things where you're looking at a robot sitting on top and you want to see how that robot's center of gravity is moving. Next slide.
All right, thanks, Jason. I think I'm back up again. We're going to look at, we're going to touch on some trends that we're seeing in the industry revolved around automation. And one of them is the rise of collaborative robots, so cobots, if you will. So these are robots that can work alongside humans. They do common repetitive tasks. By using and utilizing cobots, can reduce injury to humans. Assembly of products, can increase production. Many different cobot applications that you see out there, and they're becoming very, very popular, and can aid in automation of various repetitive tasks. Next slide, please. Predictive maintenance and self-healing machines. So, by continuously monitoring force or torque, you can predict when failures of a machine may occur. So, rather than have preventative maintenance scheduled every so often, you can look at what is the machine actually doing, and is it really time for preventative maintenance? Maybe you can move that out based on what you're actually monitoring, load conditions, rather than, again, fixed time intervals. So you can track trends over time. Leads to better and a healthier machine, right? Because it's running more efficient. So you can look at reducing anomalies, and maybe something's pressing with too much force, which may damage the machine prematurely. So by integrating sensors into these machines and automation, right, we can do more predictive maintenance. Next slide, please. Advanced process control and quality assurance. So again, integrating sensors, force or torque measurements, and provide real-time feedback, and different various manufacturing process. So you get granular data, right? For instance, extrusion machine, if you have a load cell or some force monitoring in there, you can very control the process very specifically to make sure you're maintaining product dimensions, proper extrusion process, control loop feedback, where parameters can be adjusted continuously as the machine is running to desired feedback, so that you can again have higher quality throughput, fault detection for indicate machine malfunction, and process optimization to identify process inefficiencies and or bottlenecks. Next slide, please. Machine retrofitting, so using load cells, update existing machines that human might have been doing a specific task, but by now integrating a force sensor or a torque sensor, that can now be that data can be collected automatically and be used for again preventative maintenance or something of that nature. Adding load pins to a joint, replace factory equipment, and integrating a sensor can be very beneficial for understanding what's actually occurring, in that process. Next slide, please. Industrial IoT, so Internet of Things, advancements in devices and connectivity. Machines are becoming smarter and talking to other machines. So sharing that data and making predictions, controlling on that data, using, again, you can use wireless or Bluetooth controlled sensors for communication, and the benefits are real. Next slide, please. Measurable tips and best practices.
All right, this one is mine, I think. Next slide.
Please so.
So tips and key considerations. When we start looking at instrumenting for basically adding measurements to instruments, we want to make sure that we get the right load cell for the application. We have application engineers to make sure that we can talk to you about the different applications, what you're trying to do, what you're trying to accomplish, so we can try identify that load cell. We're here to help you. What calibration is needed? You kind of want to think about that relative to what your application is, what type of fixture and mounting. So if Jeff alluded to, maybe we can instrument an existing fixture. So maybe there's a load pin that can go in there into an existing joint. Maybe there's a low profile and we're doing some type of compressive test. So what type of fixturing and mounting do you have? How much room? There's a lot of details around that. The environment, hazardous concerns. Is it going to be submerged? Is it going to be in water spray, salt water? Is it going to be around oil? What about the cable? What about the type of environment, ATEX related, things like that. So understanding what the environment that this sensor will be in is important. And that helps identify the correct type of sensor. Wiring and connections. We have a variety of options when it comes to wiring and connections. What do you need? We can do custom, we can do a variety of different things. It's just a matter of kind of identifying your needs, and then we can figure out how to get there. Consider safety and overload protection, extremely important. When you start looking at safety and overload, mechanical stops, things like that, you don't want to damage the load cells. It's an expensive investment in a lot of cases. Integration with control systems, PLCs, RS-45, Modbus, and others. So you can integrate with a variety of different control systems. So we get feedback loops. We're able to do a lot of that predictive maintenance, look at load cells, usage over time, look at its characteristics over time, variety of different things. And then consult your documentation and training. So any documentation, certifications, things like that that comes out with it, any training provided with regards to installation, whatnot, all of that is exceptionally important. And that will help you with your success of instrumenting for machine use. Next slide, please. So best practices, proper selection, load cells that are suitable for your application. So we got to look at capacity, size, accuracy. There's a lot of different factors. Will you be doing tension, compression, rotary? What is it that you need? What is it you're trying to accomplish? Then you look at mounting. You got to look at how they're mounted. They need to be mounted securely. So we want to make sure that what it's mounted to, there's no external forces or moments. Those are things that can definitely cause your readings to be deviate from what they should be. We want to make sure that we don't overload or side load, especially during mounting. Things like that can occur due to mismounting. So following the installation is very important. Calibrating your load cells. Jeff spoke to calibration to some extent, but we want to make sure that load cells are done. The calibration is done with certified equipment. Perform your calibrations to the requirements that you have. Make sure that if there's any environmental changes and accuracy changes, you can go through and get that calibration done again. And then if you have your own calibration schedule, make sure that you're following your own schedule. That will help identify any deviations, problems, or ensure that your sensors are in its best calibration shape. Next page. Environmental considerations, like I spoke to, temperature, humidity, vibration, any of those can affect a load cell, underwater, a variety of different things. So in some cases, we may not be able to, or the customer may not be able to get a load cell that is specific to what they want, but they can use a shield, or they can do something or put something around it to block for environmental considerations. Likewise, coatings, things like that. I've seen that used successfully in a variety of different situations. Wiring and connections, high quality cables. What are we looking for? What's the distance? If you start getting long cables, we have to start looking at sense wires and taking that into consideration. So those are things that we would want to discuss with you. Overload protection. I would say one of the most important parts. We don't want to overload it, no impact. So in some of our load cells, they're designed with mechanical stops so that that prevents that overload mechanically. Some they don't have that and they're susceptible to it. So they would be susceptible to a drop or an impact. So if there is a question or that is an item that could come up, definitely bring that up when you're discussing that application. Next topic, regular maintenance. Enough can't be said about regular maintenance. Perform routine inspections, checks, look for wear, damage, connectors, fray on cables. Likewise, recalibrate anything that seems to be out of the norm. We want to make sure we've got the best accuracy and reliability. If anything seems to deviate, that's where we want to make sure we want to go back and start looking at maintenance. We don't want to let maintenance go by the wayside because sometimes it's often harder to come back and correct some of those problems. Integration with control systems, integrating load cells seamlessly with control systems for real-time monitoring. So load cells connected to PLCs, human machine interfaces. So you're talking about like a dashboard or something, which allows a person to push buttons. It could be a computer, it could be a screen, a monitor. And essentially they're interacting with a machine's control and control process. So interacting with control systems, by tying into that, there's a variety of different syntaxes, languages, ways that we can do that with different devices. So the feedback loop, I think there's incredible potential. It's just a matter of making sure we get the instrumentation done well. Operator training. Ensure that personnel involved in operating or maintaining the machine are properly trained. Instructions. So in the event that, so anytime we're dealing with something that typically has a load, if something goes awry, you will end up with, in some cases, very damaged problems, alarms, warnings. Sometimes damaged products. So we want to make sure that the people using that equipment are properly trained, understand it, as well as understand the use of a load cell and the implications of like poor handling. Next slide. Documentation. Maintain detailed records of load cell specs. So we're starting to talk about CAL results, maintenance activities. This is any of the activities done within the local facility. That way you have a record of everything that's going on. It's different facilities have different quality, I guess, plans or processes. So documentation, by just doing this, it's just good and it feeds right into that. So by following a lot of these best practices, you'll maximize the performance, reliability, and longevity of your load cells, especially in building your machine applications. Next slide.
So here we're going to talk about some automation applications. Next slide, please. So here we're looking at a tire force measurement system. So, a customer needed to measure torque on a lateral force of a tire. And so we instituted one of our AT105 contactless torque sensors, the force and torque sensor, and we paired that with our SI USB4, which can take the torque and force signals and use our BlueDAC software installed on a customer's PC, and they can monitor those forces and torques in real time and graph those and store the data, do analysis on it. So that application uses our AT105 and our SI USB4 with our BlueDAC software. Next slide, please. Dual motor dynamometer. Here we're looking at our axial TQ, wireless, non-contact torque sensor. So a customer in this case had dual electric motors and needed to monitor torque on both of them simultaneously. So the torque signal from our axial TQ output from its output module directly to provided software, and you can monitor the torque in real time and measure efficiencies and various things like that during a motor dynamometer. Next slide, please. Center of gravity. So this application comes up quite often. Customers want to understand the CG of a component. So what we've done here is we have 3-axis load cells bolted between 2 rigid plates. So basically, what we're constructing is a force plate, we call it. So by spreading the 3-axis load cells out wider diameter, we can support larger moments and forces rather than using a single 3-axis load cell. So we take those signals. In this case, we tied them into our BX8, actually 2 BX8s, so they're synchronized and sampling synchronously. And we were able to put together a force plate where a customer could use it, monitor the data again on the BlueDAC software that we provide, and is an interesting application. And again, running into this application very, very often these days. Next slide, please. Roboforming. So customers' challenge was, roboforming sheet metal, and they needed to, measure the force in the application. We were able to use a 6-axis load cell on the end of the robot joint and pair it with our BX8, and they could measure forces as they're shaping this particular product into the desired shape. And again, using the BX8 with the BlueDAC software, the customer is able to precisely monitor these conditions as they're manufacturing. Next slide, please. Press load monitoring, very common application for our low profile load cells, where you may have this case, a 1000 series. It's our fatigue rated load cell in this press application. So as a customer is pressing something together, maybe they need to control to a very specific force requirement. They don't want to over press or overload. They don't want to under press and maybe it doesn't form the pieces correctly. So in here we're showing a demonstration of our fatigue rated load cell and our INF USB 3, which is a small amplifier, if you will, that then again uses the BlueDAC software to display the results and parameters on a PC screen. Next slide, please. Robotic polishing. So we touched on this earlier, but a 6-axis load cell is commonly used in these applications. So a robot rather than a human doing this repetitive test, for instance, of polishing some material or grinding. And part of the parameter is to have a very precise load and be able to measure it in all axes so that we're getting consistent results as the robot is moving to various locations or the entire surface. So by monitoring that with a 6-axis load cell and our BX8, you're able to precisely control and feed that information back to the robot so that it is always giving precise control and pressure on the device. Next slide, please. Why choose Interface as your partner? Jamie, are you taking this?
You
Yeah.
got it. So
Okay.
again, you guys provided some incredible information and insight and a lot of examples of how our products are currently being used across multiple types of machines, industrial automation. But as you heard from Jeff and Jason, the most important thing is that we collaborate on any new ideas that you have to bring sensors into an existing machine or in future designs. We can work with you as an OEM solution if you're building multiple products, or if you're just looking for a simple tensile testing machine that you want to have in your lab. So be sure to work with our engineers. We design all kinds of products. We have over 35,000 standard products, but we also can create engineer to order and custom solutions. We work and distribute our products around the world. And what we're known for is precision. If you need accuracy in measurement, then we're the people that you can work with and depend upon. We've been doing this for a long time, and we're anxious to know how we can help you. So if you're looking for something where you need people that are experts in load cell design, our engineers have proven themselves over decades of making sure that we can provide all types of solutions and capacity and configuration, different models, whatever works best. As mentioned, you have the option to customize, and that could include developing complete systems. As noted, there are many times where we want to pair multiple devices with instrumentation to ensure that you have the right amount of data back. And if you have questions, need help, let's connect. We're here to assist you in supporting your existing products as well as looking into new products to help you achieve your goals. So with that, I want to thank Jeff, Jason for a great conversation. Planted a lot of seeds. We're here to help. If you have questions, be sure to let us know. We didn't have any questions in our chat, but we will be posting this online. And again, let us know if we can help you. Thank you.
Thanks, Jamie. Thanks, Jason.
Thanks, Jamie.
Have a good day.
Have a good day, everyone.